Hello my dear students, once again welcome to your online class. So today we will be beginning a new chapter, the spectrum, from your physics textbook. So in the reduced syllabus, you have a few points to study in this chapter. The first being the deviation produced by a triangular prism, and you will also need to learn the factors on which the angle of deviation depends. The second, you will learn what is dispersion and spectrum. The third, we will learn about the electromagnetic spectrum. The fourth, we will learn the common properties to all the electromagnetic spectrum, and finally, we will learn the properties and uses of the infrared and ultraviolet radiation. So, in chapter 5 also we have studied about the deviation produced by a triangular prism, and it was like whenever a ray of light passes through the triangular prism, it always bends towards the base. So, I consider a prism A, B and C. So, one of the rays is incident on the refracting surface AC. So, instead of going in a straight line, it bends towards the normal downward, and then again here also the downward. So, we see that the incident ray, instead of going in a straight line or emerging parallel, in this case it deviates by a certain angle. Okay, so that is known as the angle of deviation del. So, what is the angle of deviation? The angle of deviation is the angle between the incident ray produced forward and the emergent ray produced backward. So, that is known as the angle of deviation. Now, this angle of deviation, it depends upon the some of the factors, like the first factor on which it depends is the angle of the prism, angle of prism. So, how does it depend? So, the angle of the prism or the angle of deviation is directly proportional to the angle of the prism. So, angle of the prism is this angle is known as the angle of prism. So, greater is the angle of the prism, so more is the angle of deviation. So, the second factor on which it depends is the angle of incidence, angle of incidence. Okay. So, with angle of incidence, the angle of deviation depends anomalously. Okay. So, initially when you go on increasing the angle of incident, the angle of deviation decreases, and for a certain value of angle of incident, that is this angle I. Okay. So, the angle of deviation will be minimum. So, that position is known as the angle, the position of minimum deviation, and on further increasing the angle of incident, the angle of deviation also increases. So, with the angle of incidence, the angle of deviation depends anomalously. Initially, with the increase in the angle of deviation, the angle of incident, the angle of deviation decreases, and further on increasing the angle of incident, the angle of deviation also increases. The third factor on which it depends is the refractive index of the medium, okay, mu. So, with the refractive index, it is directly proportional. The greater is the refractive index of the medium, the more will be the angle of deviation. And finally, the fourth factor on which the angle of deviation depends is the color of the light, or since the color of the light, it depends upon the wavelength. Okay. So, how with the wavelength? Inversely proportional. So, the red light, it deviates the least because the red has the highest wavelength. So, with the wavelength, the angle of deviation is inversely proportional. So, these are the four factors on which the angle of deviation depends: the angle of prism, the angle of incident, the refractive index of the medium, and finally, the color or the wavelength of the light which is passing through the prism. Now, coming to the second factor, the dispersion and the term, the dispersion and the spectrum. So, what is dispersion? Usually, it is seen that whenever a white light, okay, so if a white light is passed through a triangular prism, it is seen that the white light, it breaks into the 7 color. Okay, so it breaks into 7 color. Okay, so the phenomenon of splitting of the white light into the 7 color is known as dispersion. So, if asked what is the dispersion of light, so you may write the phenomenon in which the white light, when passed through a triangular prism, splits into its 7 constituent color is known as a dispersion of light. And if you keep a screen near a prism, you will obtain a colorful band. Okay. So, colorful band that we obtain on a screen is known as a spectrum. Okay, so it just appears like a rainbow with a 7 color. Now the order of the 7 colors, since the red deviates the least, so the red will be at the top. So you can remember like R, O, Y, G, B, I, V. Okay, so the red it deviates the least and the violet it deviates the most. So that is what is the dispersion and spectrum. So now coming to the electromagnetic spectrum, so they apart from light, the visible light, there are other spectrums as well to which our eyes are insensitive. Okay, so we'll learn about those spectrum according to its wavelength. So here I have drawn an electromagnetic spectrum with its wavelength given in nanometer and the frequency in hertz. Okay, so the visible light falls in the range between 400 to 800 nanometer. Okay, so that means the red has the highest wavelength in the visible light. That means the white light. So this also visible light, you can also consider it as a white light. So apart from white light, so there are many spectrums that lies beyond red, which is known as the infrared, and there are some of the spectrum that lies below violet also, which is known as ultraviolet rays. So we see that in this, the radio wave, it has the highest wavelength ranging above 10 to the power 10 nanometer, and the microwaves are those whose wavelength is between 10 to the power 6 to 10 to the power 10, and the infrared are those whose wavelength are between 800 nanometer to 10 to the power 6 nanometer. And as we know, the visible spectrum or the visible light, its wavelength ranges from 400 to 800 nanometer, and 10 to 400 nanometer is known as ultraviolet, 10 to the power minus 2 to 10 is known as X-ray, and above below 10 to the power minus 2 is known as a gamma rays. So of all of the electromagnetic spectrum, we see that the radio wave, it has the largest wavelength, and whereas the gamma ray, it has the smallest wavelength. And we also know that the wavelength and the frequency, they are inversely proportional. So that's why the one that has the largest wavelength, it will have the least frequency, and the one that has the least wavelength will have the largest frequency. So according to that, the gamma ray has the highest frequency in the electromagnetic spectrum, whereas the radio wave, it has the lowest frequency. And also remember that the electromagnetic spectrum that has a higher frequency possesses a greater amount of energy as well. So of all of these, the gamma rays has the highest energy. So that's why its penetrating power is also more than the rest of the electromagnetic spectrum, and it's more harmful than any of the other of the electromagnetic spectrum. Okay, so you need to remember all of these spectrum according to its wavelength and as well as according to its frequency as well. So now coming to the next topic, the common. Okay, so whether it's a gamma, X-ray, ultraviolet, visible, infrared, microwave or a radio wave, the first common property is all of them, they travel with the same speed, that is with the speed of light, that is 3 into 10 to the power 8 meter per second. So that is the first common property. The second one, all of them, they are electromagnetic wave, so therefore they are transverse. All of them, they are transverse in nature, and all of them, they are deflected in an electric field or a magnetic field. Okay, so there are some of the common properties between all of these. Though their physical properties may be different, their production may be different, and their uses also may be different, but there are many common properties between all of these electromagnetic spectrum. So in the reduced syllabus, you do not have to study about the properties and the uses of each of these rays. Okay, so you just have to study the uses and the properties of the ultraviolet and only the infrared ray. So you can go about its uses and the properties of the ultraviolet and the infrared in details from your book. Okay, so this is the shortest chapter in the physics textbook, and with the reduced syllabus, it has become more shorter. Okay, so you may go through this video, and if you have any problem, you are free to ask me in my WhatsApp number. Thank you.